Okay. So the first thing I have, first thing I have up here is I'm just going to take 30 numbers from my distribution that has mean of 5 and standard deviation of 10. So here they are.
All right.
All right. So what are some things you notice about those numbers?
Well, so we actually have some numbers that maybe we have a pretty low probability of picking. Like we got 30.
Uh-huh.
Which is, so that's like 2.5 standard deviations away, which has a pretty low probability.
Yeah.
And we also have like 1.
Zoom in just a little bit. Yeah.
If 1, we've got like -12.
Uh-huh.
I'm just assuming we're rounding to 4 decimal places here.
Yeah, rounding.
Approximately.
And then this number is the mean of the sample here. So in this case, it turned out the mean was 7.5.
All right.
And what should it have been? Like if this was absolutely perfect?
It should be 5.
Should be 5. So we're
pretty
picking
close.
a distribution. And then this here from 3.49 to 11.59 is what's called my 95% confidence interval. You can see I had a function here, mean confidence interval. So the confidence interval about the mean, I'm 95% sure based on this data that the mean of my distribution is between basically 3.5 and 11.5.
All right.
Okay. So maybe I'll run another one.
Here we got it. I guess this one's a bit closer. We've got 4.5, 4.6.
Yeah. And then I can run this several times. I'm trying to get an anomalous result, but I'm not getting one.
That one's
here.
pretty low.
Here we go. Yeah, this is an interesting one. Okay, yeah, this is actually a great example. So here are my numbers. So tell me some things you notice about these numbers.
Well, we have all very low numbers. Our highest number is 18. We've got a
18.
-18 over here too.
Uh-huh.
But we don't have anything in the 20s.
And we have like a minus.
And most of the numbers are single digit.
And we have a 10. And then we have a minus. No,
Here,
they're just 2 10s.
-7, -8, yeah.
All right, so the mean here is 2. And my 95% confidence interval here, so I'm 95% sure that these numbers were drawn from a distribution that has a mean between -0.75 and 4.9.
So we didn't get our actual, the actual mean we didn't get in this interval.
Right. The actual mean is, we see in this case we know that the mean is 5. But here we're 95% sure that the mean actually doesn't even include 5. And also, if I was trying to tell the difference, if I was trying to ask the question, were these numbers drawn from a distribution whose mean is greater than 0? Could I say that with 95% confidence? Can you tell me? Is the mean of this distribution greater than 0? Do we know that with 95% confidence?
Well, yeah.
Okay, why?
Well, we know this is the mean right here.
Yeah. Oh, sorry. You're right. I asked the question imprecisely. So I tell you these numbers were drawn from a distribution with some unknown mean. And I can compute the mean of these numbers, and it is 2, which is greater than 0. But I'm wondering about the mean of the distribution I picked the numbers from.
Well, and that's this number?
And the 95% confidence interval tells me that mean is somewhere between -0.75 and 4.9.
Yeah.
So can I tell for sure that the mean of the distribution I pulled these numbers from is bigger than 0?
No, because you have minus 0.75.
Yeah. It's surprising. It's surprising. So I can't say for sure that where I'm pulling the numbers from came from a distribution whose mean was bigger than 0. So what I did down here is I wanted to show you what our random sample of, if I took 10,000 numbers from my distribution. So here's what a normal distribution sort of looks like with a mean of 5 and standard deviation of 10.
Yeah.
Okay. Can you tell that the center of this distribution is bigger than 0 by looking at it?
Yeah. It's just a little
Yeah, if you like
bit.
line up your finger
Yeah.
with the top, it's just goes a bit bigger than 0.
Okay, and now I'm gonna run through some hypothesis testing down here. And what I'm gonna do is I'm gonna do 10,000 runs. I'm gonna pick 30 samples like we were doing before. And I'm gonna take the small end of the confidence interval, and we're gonna look and see how often the left-hand side is bigger than 0.
Okay.
Okay, so I run this. It takes a little bit of time to run. There we go. So the first thing, what did I print? Oh, sorry, that's my histogram of the 10,000 samples. But here's my histogram of the lower end of the confidence interval. And so here, how often would you say, just by looking at this, that the lower end is less than 0? How many of these data points are in that distribution?
Maybe about 40 or 35%.
Okay.
I would say probably closer to 25%.
Yeah, it turns out it's this number here, 25.44. So it's about a quarter of the time. I can't tell for sure if my mean is greater than 0. Or I
So-
can't tell with 95% confidence that my mean
Yeah.
is greater than 0.
So about a quarter of the time we're confusing our picking thing here.
Yeah, so I want to show you, it's actually harder to tell these distributions apart than you might think.
I mean, like if you just write them down on paper, they look pretty different. But when you try picking values from them, they actually aren't that different.
Yeah, and then I did the other thing, this number here, about 2% or 2.25%, is how often the lower end of the distribution is actually bigger than 5. So these up here are about 2.25% of the time. I'll say it's 2.5% of the time. The lower end of the distribution is actually bigger than 5.
That's bigger than I would have thought.
And we saw it once, right? We saw the high end of the distribution being below 5.
Yeah.
So we saw that happen. So this is pretty advanced statistics, and it's easy to go wrong here. Now let's say you were hoping to find, this is what we were talking about with some of the false positives. Let's say you were hoping to find that 0 was part of the confidence interval. How many experiments would you have to do of these 30 draws likely to find that to be true?
0 is inside the confidence interval.
Yeah.
You probably wouldn't have to do that many.
Well, how often did it happen?
I think we did like 5 runs and it happened once.
Okay, in my big long simulation, what % of the time did it happen?
Is it the quarter of the time?
Yeah, quarter of the time. 0 was part of the distribution. So I would just have to do the experiment 4 times,
Yeah.
and I would find 0 in my confidence interval. And that would be a true positive or a false positive?
Well,
Is the mean of my data 0?
no.
What is it?
It's 5. So that'd be a false positive.
So I would be unable to conclude that 0, that the mean was bigger than 0 25% of the time, just from randomness. Interesting, huh?
Yeah.
Yeah.
It was a difficult subject, but I just wanted to show you how, I wanted to give you a sort of the simplest example I could think of, one where we know for sure what the mean is, and then we see randomly we can't exclude 0 about a quarter of the time. It's surprising.
Yeah.
All right, good work this morning, guys.